The first chemical reaction I'll be explaining today is zinc nitrate plus potassium. Now the reaction type that is happening is called single displacement, which means like elements, in this case a metal and a metal, zinc and potassium, swap places to create a new ionic compound and a single element. So this creates potassium nitrate and zinc. The next thing to do is to find the valence charges of each element. For zinc, it needs to lose 2 electrons to create a full outer shell, which means it has a charge of +2. Now finding the valence charge for nitrate is a bit different, and also writing the chemical formula. A thing that helps is nic-decamyl eta-clan for separate in Phoenix, whereas the consonants in Nic represent the 3 oxygen atoms in the formula. The single vowel represents the charge, so the charge of nitrate is -1. The thing about nitrate is it's a polyatomic ion, which means even though it consists of both nitrogen and oxygen, it acts as a single ion. And potassium needs to lose 1 electron to make a full outer shell, so its charge is +1. To create the chemical formula, the elements in the ionic compounds need to have a balanced charge. So the charge of one element minus the charge of another element has to equal 0. Since zinc has a charge of +2 and nitrate only has a charge of -1, there needs to be 2 nitrate ions to balance the charges. Now remember, nitrate acts as a single ion, so it needs to be in brackets, so that the subscript outside the brackets can be applied to everything in nitrate. And since potassium is by itself, it's just +K. Now for the product side, since potassium has a charge of 1 and nitrate -1, it's already balanced. And again, since zinc is by itself, it's just +Cn. The equation I have just written out is unbalanced, and is also known as the skeletal equation. These equations need to be balanced because of the law of conservation of mass. This law states that in a chemical reaction, the total mass of the reactants is always equal to the total mass of the products. This means each side needs to have the same amount of atoms for each element. The way I learned to balance equations was to make a table, with one side being the reactants and the other side being the products. And on both sides, write each element as an individual. Then count the atoms on both sides. To count the atoms for nitrate, multiply the 2 by the invisible 1 for nitrogen and the 2 by the 3 in oxygen. To balance nitrate, the entire ionic compound needs to be multiplied by 2 on the product side. But now the potassium's unbalanced, so the potassium on the reactant side needs to be multiplied by 2 to balance it out. The numbers that the elements were multiplied by now become the coefficient in that specific part of the equation. The coefficient is the number that comes before the elements. This is just showing that the 2 out in front applies to everything after. Again, the reaction type is single displacement. The next chemical reaction is calcium chloride plus aluminum sulfate. This reaction type is called double displacement. It exchanges the cations or anions of the 2 ionic compounds to create 2 new ionic compounds. In this instance, I exchanged sulfate for chloride, which produced calcium sulfate plus aluminum chloride. Like before, the next step is to find the charges of each element. Calcium needs to lose 2 electrons to have a full outer shell, so its charge is +2. Calcium needs to gain an electron to have a full outer shell, so its charge is -1. Aluminum needs to lose 3 electrons, so its charge is +3. Sulfate is another polyatomic ion, and the word that corresponds with it in the saying is supper. Since calcium has a valence charge of +2 and chlorine only has a charge of -1, there needs to be 2 chlorine atoms to balance the charges. Aluminum has a charge of +3 and sulfate has a charge of -2. To balance the charges, there needs to be a common multiple between the 2 atoms. In this case, it is 6. Therefore, aluminum needs 2 atoms and sulfate needs 3 atoms to balance the charges. Remember to put the polyatomic ion in brackets. For the product side, calcium and sulfate are already balanced. And for aluminum chloride, there needs to be 3 chlorine atoms to balance out the charges. Now it's time for the process of balancing the equation to begin. Write each element on both sides like before. Now count the atoms on both sides. First, I want to balance sulfate. To do this, I have to multiply calcium sulfate on the product side by 3. Now calcium is imbalanced, so I'm going to multiply calcium chloride on the reactant side by 3 to balance it out. Now chlorine is unbalanced, but fortunately on the product side, aluminum and chlorine are together, so I can multiply both of them by 2 to balance both out. Again, the number that each element was multiplied by is now the coefficient to that specific part of the equation. Now some similarities and differences between single displacement and double displacement. Both swap or exchange like elements. One replaces an element for another in a compound, single displacement, and the other exchanges the cations or the anions of 2 ionic compounds.